Good morning, everyone. Today is November 7th, and welcome to another live lesson. Today we will be learning about transformations of exponential and logarithmic functions. So let's get started. So a few properties about exponential functions. Hopefully you remember this from grade 11. The general equation is y is equal to a times b to the power of k x minus d in brackets and then plus c, where c is your vertical translation, d is your horizontal translation, moving it left to right, k is your horizontal stretch or compression, and a is your vertical stretch or compression, and b is your base function, y equals b to the power of x. And here's some examples. If a is greater than 0 and b is greater than 1, so an example of that is y equals 2 to the power of x, we have a general exponential function that kind of looks like this. It's a growing function, goes up in red. And if we have a is greater than 0, but b is a fractions between 0 and 1. So an example would that be y equals 1/2 to the power of x. That is an example of the function represented by this green graph here. You can see it's going down, 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 and it has a horizontal asymptote at y equals 0. And if you remember correctly, your asymptotes are affected by one of these values. We're going to get into that. Here we have an example for 3 when a is less than 0, so meaning a is negative, and b is greater than 1. So an example would be y equals -1 brackets 2 to the power of x. The graph shown in blue represents this scenario, and you can see it's going down. It's a decreasing function. It also has a horizontal asymptote at 0. And yeah. And example 4, when a is negative, but b is between 0 and 1. So an example of that is y equals -1, 1/2 to the power of x. And this is an increasing function. It's going up, 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 up. And it has a horizontal asymptote at 0. And you'll notice that the y-intercepts for the first two examples are at 1. And the y-intercepts for the last two examples are at -1. So to graph the base function y equals b to the x, we find the following key features. Horizontal asymptotes starts at y equals 0 and then can be shifted by your c value. So your horizontal asymptote, depending on your c value, usually that is what it's going to be. So if my c value, let's say an example is y equals 2 to the power of x plus 1. So in this example, I would expect my horizontal asymptote to be y equals 1, because that is my c value. For the y-intercept, the way to solve that is to set x equals 0 and then solve. So the y-intercept can change. Remember, when we're transforming functions, we are changing points. So don't expect the y-intercept to always be at 1, and don't expect the horizontal asymptote always to be at 0. So in this example here, y equals 2 to the x plus 1, if I set x to 0, then my y-intercept is going to be 1 plus 1, because anything to the power of 0 is 1, and that is 2. So in this example, my y-intercept is 2. And then at least one other point to be sure of the shape, common to choose x equals 1 and solve for y. So just pick another point for x, substitute it into the equation, and solve. And that is how you can kind of get a general idea of your exponential function. Okay, part 2. Transformations of exponential functions. Let's do an example. Here we have example 1. We're going to sketch the graph of f of x equals 2 times 3 to the power of x plus 4, and then minus 5. And we have a function g of x, which is equal to -3 to the power of 1/2 times x plus 4. Let's see how we can do this. What is the base function for both of these transformed exponential functions? And the base function is just your base value, which is 3. In this case, the base value is the same. So we can use that as our quote-unquote parent function. So we draw a table, and we get some values for our parent function or our base function. And x values we can choose as -1, 0, 1, and then we usually like to write our horizontal asymptote. So if I substitute -1 into this equation, what do I get? Well, it's going to be y equals 3 to the power of -1. And that is just 1 over 3. And we can write this in decimal form, which is fine, makes it easier to graph. And let's pick y equals 3 to the power of 0. Anything to the power of 0 is just 1. And y equals 3 to the power of 1, that's 3. And you can see it's growing each time by a factor of 3. As for the horizontal asymptote, that is my c value in this case. Since this is your base function, c value is 0. Y equals 0 is the horizontal asymptote. Same thing here, except we are going to use our mapping notation. And if you remember from grade 11, mapping notation is ay plus c and x over k plus d. So let's label our values here. My a value for the function f is 2. 3 is my base or b value. So that's not one of the transformation values. There is no k value, or rather k is 1, because that is the value that is being multiplied by x. My d value is not positive 4, it is negative 4, remember that. And my c value is -5. So let's plug in these into this equation, x over k plus d. K is 1, so x over 1 is just x. And d is -4, so that's x minus 4. And as for my y column, a is 2, so it's going to be 2y minus 5. And I transform the values from my base function using this equation. So substitute -1 into x minus 4. -1 minus 4 is -5. 0 minus 4 is -4. And 1 minus 4 is -3. As for my y values, substitute 0.33. So what's 2 times 0.33? That's going to be 0.66. And 0.66 minus 5 is going to be 4.33. And that's negative. Substitute 1. 2 times 1 is 2. 2 minus 5 is -3. And in this case, we have 3. 3 times 2 is 6. 6 minus 5 is 1. And the horizontal asymptote in this example is y equals my c value, which is -5. And we're going to do the same thing now for this example here, g of x, except the transformation values are different. So in this case, my a value is -1. My k value is 1/2. There is no d value because there's no value that's being added or subtracted to x. And my c value is +4. So x over 1/2, or x divided by 1/2, is just going to be 2x plus d. And since we don't have a d value, it's just 2x. As for a, it's negative. That's going to be -y plus 4. Now we substitute the same base values from that first table there. So -1 goes into x, that's -2. 0, that's 0. 1 times 2 is 2. And the horizontal asymptote, we will find out soon enough. 0.33 is my y value, so -0.33. This is going to be then +3.66. Substitute 1, -1, so -1 plus 4, that's 3. And 3 times -1 is -3, so that's going to be +1. As for the horizontal asymptote, it is our c value, which is y equals 4. Now that we've made our table of values, we need to graph these functions. So let's take a graph. Actually, you know what? Hold on. Let's paste it here. All right. So f of x will be in red. We have -5. Actually, sorry. When we're drawing exponential functions, the first place you should probably start is the horizontal asymptote. So get a dashed line. And our horizontal asymptote is at -5. So here we have -5. We're going to do it in red. So -5 is the horizontal asymptote. Now, our value is -5 and -4.33. So x value is -5, -4.33. That's around here. And we have -4 and -3, so that's here. We have -3 and 1. Wait, -3 and 1. Oh, that's here. All right. And we can graph this now. So we have a general idea of what this function is going to look like. And there we go. It's a little off. It's kind of hard to do this with my mouse here. But you get the general idea. Horizontal asymptote graph is going up like that. That's f of x. Let's do g of x in blue. G of x is y equals 4. That is the horizontal asymptote. So let's start with that. And it's at y equals 4. So it's over here. And then our values are -2 and 3.66. So x value -2, 3.66. So 3.6 is roughly there. Then we have 0 and 3. And we have 2 and 1. So 1, 2, and 1. So if you're connecting these dots, you know it's got to go something like this. And there you have it, the general graph of g of x. And if you want to graph the basic function, the base function there, that has a horizontal asymptote at y equals 0. And it's going to have a y-intercept of 0, 1. And we know we have -1 and 0.33, so that's here. And 1 and 3 there, so it's going to go something like this. That is our base function. There it is. So this is how you graph exponential functions and transformations of exponential functions.